Hello, welcome to my tutorial on SUVAT equations of motion. So first we're going to derive the equations of motion. So there are four equations you need to remember, and they all involve deriving sets of equations. So this first one, this allows you to derive almost all three of them. The other three that come along. So if A equals v minus u over t, or basically the final velocity minus the initial velocity, all divided by time, you can find acceleration. So rearranging this, we can get at equaling v minus u, and then v equaling u plus at. So if you take the u from both sides, you will get u plus at. This is just another way of writing it neater. And then for equation 2, s equals u plus v over 2. So it's the mean velocity times time, and s is displacement. And for 3, if v equals u plus at, you substitute equation 1 into number 2, and then s equals u plus at times t, and then s equals 2ut over 2 plus at squared over 2, because you have to expand the bracket with t, and then this makes s equals ut plus half at squared. So we'll move on to the next one, equation 4, and find out how that one is derived. So using equations 1 and 2 now, you use equation 1 in this form here. A is v minus u over t, and then using s equals u plus v over 2 times t, exactly the same, you don't need to rearrange it, and then s equals u plus v over 2 times t, you times both sides by s, making u plus v over 2 times t, and then as making this, and then 2as equals v minus u over v minus u. So then you expand it, and notice that this part cancels here. So then clearing it up, 2as equals v squared minus u squared. So then v squared equals u squared plus 2as, and that's it. You're done with the four equations of motion. If you remember these four equations of motion, just flick back to the other three. So v equals u plus at, and s equals u plus v over 2 times t, and s equals ut plus half at squared. You should be able to solve problems with constant acceleration. This is where you assume that the initial velocity is always 0. So we'll have a look at a SUVAT calculation. So writing SUVAT down the page on your exam paper is a very useful thing to do. It organises all your numbers from the question. So I'll read the question out. A tile falls from a roof 25 meters high. Calculate its speed when it hits the ground and how long it takes to fall, taking g to be 9.8 meters a second squared. So to visualize what I just said in words, we have a block here, and here's the wall of the house, and it's 25 meters, and here's the falling block or tile, and it falls at 9.8 ms minus 2. So then you choose the equation with the only one unknown quantity. So we'll choose v squared first, and then you can substitute u and a and s into the equation, given v squared equals 490, taking the square root of 490, this equals 22.1 ms minus 1. And then to find t, you use s equals ut plus half at squared. Then 25 equals 0 plus half times 9.8 times t squared. So then you rearrange to make t squared equaling 25 over 4.9. So half times 9.8 is 4.9. And then you have t squared on that side. And divide. And this equals 5.102 to 3 significant figures. And then you take the square root of 5.102 to equal 2.258, which is roughly 2.3 seconds, and that is our value for t. So t is 2.3 seconds and v is 22.1 ms minus 1. So now we'll look at another example. So this particular example is a car accelerates steadily from rest at a rate of 4.2 ms minus 2. This is accelerating for 6 seconds. So A is to calculate its final speed. So the final velocity v equals u plus at. Simple job here, u is 0, and then you times 4.2, the acceleration, by the time, 6 seconds, and then this makes 25.2 ms minus 1. That's v sorted, you're done. Now you write out SUVAT again with the new information in the box. Using s equals u plus v times t over 2, you then substitute in the numbers 0 from u, 25.2 from v, and 6 from t, and s equals 75.6 meters. Alternatively, you could use s equals ut plus half at squared, with s being 0 plus half times 4.2 times 36, or 6 squared from t. But you should get 75.6 meters both ways. So we'll look at some questions now. A skydiver jumps from an aeroplane when it is flying horizontally. She accelerates due to gravity for 5 seconds. Calculate her maximum vertical velocity. How far does she fall in the time? And part 2. A motorcyclist slows down uniformly as he approaches a red light. He takes 3.2 seconds to come to a halt and travels 40 meters in this time. How fast was he travelling initially? Calculate his acceleration. A stream provides a constant acceleration of 6 ms minus 2. A toy boat is pushed directly against the current and is then released from a point 1.2 meters upstream from a small waterfall. Just before it reaches the waterfall, it is travelling 40 meters in this time. How fast was he travelling initially? This is the toy boat. What is the maximum distance upstream from the waterfall that the boat reaches? So I'll give you a slight pause, and right, we'll look through the answers now. So for question 1, part A, you use v equals u plus at, with u being 0 and at being 5 times minus 9.81, as the object is going downwards, the skydiver is going downwards, so when it's going downwards you take up as positive in the equations of motion, so you have a minus there. If you did it the other way, and that's okay, but usually in exams they like you to take upwards as positive, so downwards is always negative. And when I say up, I mean on your exam paper, north is upwards. So if you're one of those people who writes who writes with the paper facing like this because you have trouble writing, then you just take it like that. That is upwards to you if you're writing like that. And for part B, S equals U plus V over 2 times T, and then S equals minus 49.05 from the previous question over 2 times 5, and that equals minus 122.626. Alternatively, you can use S equals UT plus half AT squared as you have all the values. Remembering that that's just square the T, that makes 25. So S would equal minus 122.625 if you substitute the numbers incorrectly and you press the right number on your calculator. So we'll look at question 2 now, when it loads. So S is 40, U is we don't know, V is 0, and T is 3.2. So using S equals U plus V over 2 times T, that's 1 mark. 40 equals 3.2 U times U over 2. So U equals 80 over 3.2 equaling 25 ms minus 1. And then B is V squared equaling that equals U squared plus 2 AS. Using that equation gives you 1 mark. 0 equals 25 squared plus 80A, and then minus 80A equals 625. A is minus 7.8 ms minus 2, taken upwards as positive. And question number 3, S is 1.2 meters, V squared equals U squared plus 2AS, that gives you 1 mark. 1 mark there. 5 squared plus U squared equals 5 squared plus U equals U squared plus 2 times 6 times 1.2, and this equals U squared equals 10.6, and then square rooting 10.6 gives you minus 3.26. So that steps a mark and that steps a mark. 3 marks can be got for this question, and that was part A. So for part B, knowing all these values, you can use V squared equals U squared plus 2AS, and then you can rearrange to find S. So S squared would equal 0 plus 12 times 5, and then S is 25 over 12, which is 2.08 meters. So that's it for this tutorial. Hope to see you next time.